Okay, I think we'll get started then. Doesn't look like anybody else is rushing in. Um, so welcome to this session on the fourth day of EAMS. It's the afternoon session here in the UK. The plan is for me to deliver some training on numbers with only a few of us present here. I think there'll be space to do whatever we like. So I have some slides which I can work through. I have my usual spiel. But if there's anything you want to know about numbers at all, then please ask. You can either put a question in the Matrix chat. I'll put a link to that in the Zoom chat here, or just use Zoom to get my attention, use the raise hand feature and just start talking. Okay, so I think I'll get started. I think what would be helpful would be to know who has used Numbers before, who has some experience of using it in the past. I know we've got a few people that have been coming to EAMS for a few years now. So if you could just maybe write in the Zoom chat whether you've ever used Numbers before, and that will help me decide what I'm going to do in this session. Okay, completely new to you, David. Good. Right. Okay. So I'll make sure I can see the chat. Okay, so I'll go through my usual bit of chat about what Numbers is and what it does, and then I'll do a short demo, and then maybe we'll work through how you create a question using Numbers. Okay, so that's my plan. Introduce Numbers, do a bit of a demo, see if there's anything in particular we want to get some detail on, and then we'll spend some time showing how to use the Numbers editor, and then I'm sure there'll be time for questions afterwards. You can ask a question at any point during the session, and I'm happy to interrupt what I'm doing and talk about it. Okay, so Numbers is an open source web-based e-assessment system. It's aimed at numerate disciplines. So it's I work in a maths department. The reason it exists is for maths exams, but it's used for all sorts of other subjects. So we just say it's aimed at numerate disciplines. So I'm part of the digital learning unit in Newcastle University's School of Maths, Stats and Physics, and my job basically is to develop numbers. So the idea behind Numbers was sort of motivated by our previous experiences with online assessment. We needed a system that was scalable to hundreds or thousands of users, reliable and accessible to many students. And those factors have become more important over the years. Something I really strive for is that it's easy to use, both for the students and for question authors, for the lecturers who are trying to deliver numbers material. So ideally, you don't have to learn a lot of programming stuff or really technical matters before you can start using numbers. I really think one of the big benefits of automatic online assessment is that you can get that immediate feedback, and having useful feedback is really good. So there are a lot of features in Numbers that will help you to deliver really specific feedback to students. Maths is a huge subject. There's tons of stuff and none of it works the same. There's no common ground between different fields of maths. So it's really important that Numbers is customizable and extensible. So over the years, we've written lots of extensions to do different things, to either work with different kinds of objects or to display different things in Numbers. Now, I think one of the hard parts for taking up e-assessment is that, do you have the right software installed? Does it integrate with your learning environment? So one of the core things in Numbas, and something that really dictates a lot of how it works, is that it can work completely standalone. A Numbas exam is just a web page that runs completely in your browser, and there's no backend server doing anything. So that means you can just point people to a web address if you just want to do a formative test, or you can integrate it with your learning environment either through SCORM or LTI. And finally, the last item on my bullet point list there is there's lots of maths features. That's really the thing that means that's why we have these separate assessment systems for maths, because we do a lot of stuff that the standard assessment systems for other subjects, where students might just want to write an essay or do some multiple choice quizzes, that isn't really sufficient for maths. So we've been using Numbas in Newcastle for just over 10 years now. We started work on it in around about 2009. So quite a few years, in fact. We use it sort of throughout our maths course, and then in a lot of other programs at Newcastle. So before students even get here, they have some formative tests that they access. That sort of helps them to convince themselves that they've covered the material they need to before they come into our maths degree, or if they haven't, then it helps them to get up to speed. Once students arrive, we do a diagnostic test, again in Numbas, and that helps us identify students who need help and where they need help. And then just throughout the course, we have big banks of practice material available through Canvas, that's our learning environment, to supplement the lecture material. So we'll direct students to have a go at some quizzes on topics they've just read. And quite often when it comes up to exam revision, students will come back to Numbas material to check that they've remembered the things they were taught. We do quite a lot of in-course assessment, so sort of low stakes summative stuff. Students will get a few % of the course credit for doing some Numbas quizzes, and the aim there really is to keep students engaged, and to, since the in-course stuff is a little bit easier than the final assessment, sort of make them believe that they can really do the course. And if they're struggling with it, then they can act on that and get some help. Elsewhere in the other courses in the university, some of the scientists are doing good stuff with lab exercises where they'll do an actual physical thing. They'll take some measurements, put those into Numbas, and then the calculations and conclusions they draw based on that can be marked automatically. I think that's saving them a huge amount of marking time. And then we're also using Numbas for final exams, typically in a hybrid mode. And I think we've talked about this in other talks at EAMS, where some of the more procedural questions will be dealt with automatically in Numbas, and then students will write out long form answers to theoretical questions on paper. Okay, so there's a list of subjects using Numbas. It's the numerate disciplines really. So starting with maths and stats, the sciences, physics. We do a lot of service teaching for things like business studies, psychology. Many of the scientific disciplines have developed some Numbas material. And Numbas is used all around the world. We support a public editor that anyone is free to use, and that's, as far as we can tell, used by around about 1,500 institutions in some sense. I'm measuring people that have registered an account on the editor. We can't track any more detail than that. And there's a huge bank of material to use there. There's over 10,000 questions available to use under Creative Commons licenses. There's a lot more, a couple of orders of magnitude more stuff that people have made for use privately. Okay, so I'm going to switch to my demo now and show you what Numbas looks like, what it can do. And just this afternoon, I've added a new start here question, because I always do this demo and then realize there isn't something that really succinctly summarizes what Numbers does. So this is a Numbers exam. It's in menu mode. So I'm showing a list of questions and I can pick what I want to do. For a summative assessment, we would use the sequential mode, where students are just shown a list of questions they have to work through. This is really good for when you have formative material. So this is a Numbers question. We start with a statement where you give some information to the student, and then there's a series of parts where they enter answers. This one's about, I've got to work out the formula for this mystery function. I'm shown a plot. Looks kind of wavy, kind of periodic, and I have to work out what the formula is. Something I can do, I can look at this plot. I've got pretty good vision, minus my glasses. But an accessibility problem with diagrams is how do you make that information available to people who can't see it or can't see it very well. And also, this is, I think, just a good tool to have anyway for my benefit. So the first thing I can do in this question is I can give a value of x, and it will tell me what's the corresponding value of the function, what's f of x. So I can maybe say 1 and click submit part, and it'll say f of 1 is this kind of thing. I can check that it's really, is it 0 at x equals 4? Yeah, it is. So I can use that, and I'm going to use that a bit later on because I want to write down a formula for f of x. I want to write down a algebraic form of it. And this is going to show you another feature of Numbers. I've got, as I write here, I'm writing, we call it JME syntax. It's just kind of, it's the kind of thing that everything accepts: calculators, computer algebra systems. We give students an introductory test that sort of takes them through the syntax for typing into these things, but really it's, I think, so conventional now that students don't really have trouble with this. Anyway, as I'm typing this, I'm shown a rendering of what I've written in that 2D conventional maths notation. That's LaTeX. So I can see how the computer's interpreted my expression. But also for this question in particular, just above, I'm shown that plot again, but I'm also shown in a thick black line my function. So I've written sine of x over 2 here, and that does look like sine of x over 2. I think this thing's going to be 3 times sine of x over 2. I think the peak is at 3. I could go up to that previous part and check. I pick one of the points where it looks like it's highest, maybe f of 2. Check what it should be. Yeah, so the maximum is 3. So I can do that, and I'm going to narrow in on this, and I'll skip some steps. I already know how this is set up. I know how this is set up, but I don't know exactly what the values are. These are randomly picked each time the question starts. So I'm just sort of going back and forth here, changing a lot of things. And this is a really good formative exercise. It doesn't matter that I don't know immediately, and I'm getting a lot of feedback from the computer. For a summative exercise, you might not do that. There we go. So I think I've found it, because my plot matches up exactly with the plot that was already there. Now the next part, I'm asked what's f of 254, which might be quite hard to work out, but I'll skip some thinking for you. That's a multiple of the period of the function, so I think it's going to be 0. It's either 0 or 3, or minus 3. Hey, it's minus 3. But what's important here is this part. It doesn't just use the built-in function that we're expecting. If I've given the wrong function here, I would want to get the right. I would want to get credit for applying that correctly in the next part. So if I say y equals x, that's not right. But it said that this part's marking depends on your answers to other parts, which you've changed. So this is an opportunity to submit this again. What I want to do is that would have to be 254, wouldn't it? If y equals x. So adaptive marking is something you can do in Numbers. I replace a question variable with what the student wrote, and then that affects the marking for subsequent parts. So I got partial credit here. I applied my thing correctly, but it wasn't really the right answer. Anyway, students really like this kind of partial marks. It really helps you identify where you've gone wrong. I didn't go wrong on this last bit. I went wrong earlier on. Okay, I'll go back and I'll go back to the rest of my demo now. There are loads of part types. So when you, the part of a question where you ask the student for an answer, exactly what format that answer is, that's the part type. You can ask for a mathematical expression. That's what we had just there. You can ask for a number. You can ask the student to enter a matrix of numbers. Just some plain text, which I don't think I've ever used. And then there's a variety of multiple choice types. And I'll show you all of these. So we've got numbers, mathematical expressions, matrices, text, multiple choice. So you can ask to choose one, choose several, or to match up like a grid, matching choices with answers. So those multiple choice types are the kinds of things that are normally built into a quiz engine, but you can do some really sophisticated marking or randomization in Numbers. There are also custom part types. This one is really a convenience for the question author. Instead of having to set up separate options for yes and no each time you make up one of these parts, the interface will ask you, just is the answer yes, and it will take care of setting up the input. There are some more complicated custom part types I can show you in a bit. And then finally, you can, if you want to have several inputs in the same part, so there might be a few components to the same question, then you can use a gap fill. Okay, what else can I show you? You can stick images in, you can stick videos in. I don't think that's really incredible these days anymore. Back when we started, it was notable. I'm just showing you a few more features. One thing that can really help students sort of that tailored feedback, or with getting partial credit for things that are almost right, is the idea of alternative answers. So that's the idea that you don't just set up a question and say, I'm expecting to see this answer, and give the student credit if they give that answer. You might give a few different options that would maybe give the student different feedback when you see them, or would maybe be a bit less strict and give partial credit. So in this question, I've got 2 4-digit numbers to add, and that's not something I can do immediately in my head, but I can use the equals rule. If I just take the first digit of each one and think of the rest as zeros, I can do that in my head. I can get close enough here. Oh, crikey, so I'm not even within 1,000. Oh yeah, some things add up here. Yeah. So as I get closer and closer to the right answer, I will get more marks. This question has it has the correct version set up, and then it has alternatives set up for ever widening ranges of accepted values, and we've got some specific feedback there. You might use these for questions where you're expecting students to make some mistakes quite often. So if there's something that loads of students get wrong, you could catch that and give them some specific feedback, like, oh, it looks like you forgot to whatever, expand these brackets or carry the 1, those kinds of mistakes. Or as in this case, you can just give partial credit for slightly right answers, slightly wrong answers. Right, something else that Numbers can do that's really not the usual mode for an online assessment is explore mode. And here, this is really, instead of just showing the student a fixed list of things to do, they can choose their own path through an experiment, or you can choose the path for them based on what they do. So this example is about designing an experiment. I'm going to be asked, I want to decide if a coin is fair. So the basic structure is coded in, like that I'll flip a coin and then note down how many times it comes up heads, make a decision, but I get to pick the parameters here. So I'm going to be led through a series of steps. So I'll say I'll flip my coin 5 times because I don't want to spend all day flipping coins. Pick another parameter. How many times would it have to come up heads to make me think it's biased? I'll say 4. 3 sounds about average. 4 would be too many. Now, as I'm doing this, I might have some options. Like I say, this came up tails 5 times. I'll move on. So there wasn't an option to move on until I'd entered an answer here. On this one, I get an option before I've entered any answers. If I'm having trouble working out this percentage that I'm asked to do here, I might want to be shown a table of frequencies, and that's based on the data I just entered. And there's some marking happening, so I've lost a point for having a look at this hint. Yeah, so that's explore mode. This exercise doesn't branch very much. We do have some questions that are really about, if you're following through an algorithm, you might let the student choose which steps to take. Or if there are a few different ways of solving a problem, give them different paths for each way. Yeah, so that's explore mode. Right, and I've shown you some adaptive marking. And we have a couple of extensions here, which I'll just note. We have an extension for picking names of people. That's based on census data or birth data, so from the real world, which really helps with inclusion, really, representation. It's very hard to pick good names for word problems. So just let the computer do it. And another extension we have is adding functionality for units, which the scientists really care about. I got away with not thinking about units for a lot of years until the chemists came to me and said, oh, this really needs to be in, I don't know, grams, whatever they use. So that's the thing. Right. So my plan, I'll go back to my plan. That's my demo. That was a glimpse of what Numbas can do. There's absolutely tons, and there's no way I could show everything in an hour. So you're getting a very brief tour. I think what might be nice to do now would be to have a go at using the Numbas editor. So this is open to everyone, hosted through Math Center, which is it was a sort of resource center for higher ed institutions in the UK, now sort of maintained by a couple of universities, one of which is Newcastle. So numbas.mathcenter.ac.uk, you can go there and create an account and either use the existing content or make your own. So I'll go to that now. So I already have an account here. If you don't have an account, when you go to this, you'll go through the process of creating one. And I think it's really hard to make sure everybody's keeping up in an online session. So I'll go through here and show you some stuff, and you can have a go on your own. Either try and keep up or have a go later. Anyway, so this is what it looks like. There's space for organizing my material into projects. So for each module that we teach, we typically have a separate project. I can explore the public database. So this is going to show me stuff that's been published for anyone to use. when you make new content on the editor, it's limited to only you can see it, but then you can publish it if you want to for everyone to have a look. So for example, we've published a lot of material under content created by Newcastle or transition to university. Okay, so that's one thing you could do. But what I want to do is to write my own question. And in fact, I want to show you the tutorials. So at the top of every page in the editor, there's this help link, which goes to the documentation, which hopefully I have open somewhere. And this really contains a full reference for everything in Numbas. It got lots of information about how to get started using it, accessibility and so on. But what we're interested in is the getting started tutorials. And I'll skip a couple of steps and go to writing your first question. So this will take us through the process of writing a fairly straightforward question where we ask the student for a number. We'll just check, really. It's an assessment of multiplication. So the prompt's going to be, Chris eats 7 apples per day. How many apples does he eat per week? And the inspiration for this is my colleague Chris, who really does eat a huge number of apples per day. So we're given this number and the student's got to multiply it by the number of days in a week, 7. Tell us what that number is. So I will make a new question. I'll give the name something like rate per week. I won't calculate rate per week. It's surprisingly important how you name a question. We find often when people start, they'll name questions, they'll just call them like question 1 or whatever, section 1, something that doesn't really have any meaning outside of the specific course that they're delivering at the time. And that makes it really difficult once it comes time to either rearrange the course or for someone else to reuse the question. It's hard to know what different items are for. So we try and say the name of a question should describe what you have to do. What's the objective? So there we go. Right. Now this is the question editor. There are lots of parts to it. As I said, there's absolutely tons in Numbas. But there are really, these first 4 items along here are the most important ones. In the statement, we'll give the student some information to start with. Just something they'll need to use to answer questions later on. In the parts tab is where we can set up parts where the student is given somewhere to write an answer and it will be marked. And there are lots of part types. The ones I showed you are highlighted, and then there are more. The custom part types, these are provided by extensions usually that do more stuff. So things like marking code written in Python or R. We have some stuff with code words. That's from our coding theory module that I made. There's all sorts of things here. Loads, but I'm not going to use any of those. So we want to ask the student for a number. I'll use a number entry part. I'll come back to setting up that up later once I've walked through some of these other bits. Now the variables tab is where you can set up randomization in a question. So you can define variables which, when the student runs a numbers question, they'll get some values picked, and then those are used in the text or in the marking. We'll set some of those up later on. That's all you really need to set up a numbers question. The advice section is where you can give a fully worked solution. And for formative material, this is really useful. Students really like, if they're shown a question and don't know what to do, being able to see a fully worked solution is helpful. And this is just text that I, as the question author, have to write. seeing the expected answer, that happens automatically, but that doesn't really help you if you're stuck about how to get there. I'll write some text later on once I've got our question. Right, so I'll say in the statement, I need to give the student the information that they need. So I'll say 7 apples per day. That's the information. And then over in the part, we've set up a number entry part. And the first thing I have to do is give the student a prompt, ask them a question, tell them what to do. So I say, how many apples does Chris? Ooh, can't type. I still can't type. How many apples does Chris eat per week? Okay. I said it was 7 per day, so I know that the answer should be 49 here. So in the marking settings tab, that's where I set up how the marking will work. For number entry, it takes a minimum and a maximum accepted value, and anything in that range is accepted as correct. Here, the answer is a whole number, so it's the same thing in both. But when the student's doing some calculation, you might want to allow some room for error. Okay, this question works now, I think. If I click on the run button, I will see it as a student would. There we go. So I get my statement, I get the prompt, and I can write the answer and get some feedback. It's always worth checking that a wrong answer is marked wrong. That's important. So this is fine. The obvious next thing to do here is to randomize this question. We've got a number that's shown to the student, and that could change. So I'll do that. So back at the prompt, I'll replace this 7 with variable name in curly braces. And those curly braces mean take the value of this variable and put it in here. I'm going to call it apples per day, because that's what it represents. Over in the variables tab, I've automatically had an entry has been added for that because I added a reference to it, so it needs to be defined. Okay, so I can either use some code to find this variable. The language that Numbas uses is called JME, and it's unique to Numbas, really. Numbas comes from a lineage of systems that goes back into the 1980s. The design was inspired by systems that we'd previously used, and JME was the name that they used for their syntax, so we've kept that. But I can do some other things. There are some helpful templates, one of which is random number from a range. So I want this really to be a whole number between, let's say, 2 and 8. So I fill in those boxes, and that makes up the code for this variable for me. I'm showing a representative generated value, and I can click on a button to see more. Once we get to more complicated stuff, that's really helpful to see that it's doing the right thing. I find it really hard to code without that immediate feedback of am I producing the right values. So that's there. I can give this as a description, and that's, again, it's free text, and it's all about helping whoever comes to look at this question later, helping them understand what this is for. You always underestimate how much you'll forget. So I write a description here. There's the number of apples Chris eats per day. I already chose a pretty good name for this variable, but there's a bit more. When there's some long calculation, you might want to explain exactly what that's doing, or you might want to describe some assumptions that are baked into the definition. Okay, so I've used this variable in the statement. I need to then use it again in the marking, because that's still fixed to 49. So I can either write 7 times apples per day in both of these boxes, and that would work, or I can make up another variable for apples per week, which I'll do. So again, both values are the same variable. And again, because I've referred to this variable and it doesn't exist, there's an entry has been added here. I need to define it. So I'll call it 7 times apples per day. And there we've got the value, and that looks correct. Right. So I can run this again, I suppose. So now we've got Chris eats 8 apples per day, and what's 7 times 8? 56. I think there. Yeah, it looks good. And we'll check that 49 is no longer correct. There we go. So this question seems fine. What might I do if I'm happy with this question and it's finished? I would pass it on to someone else who would check it over for me. Within Numbas, there's tools for managing that proofreading checking step. Up at the top, there's a status button where I can say, once I've checked a question, does it need, so I'll say it needs to be tested. Someone else will come in and maybe say, oh, this has some problems, you have to go and fix them. We can have a discussion in the editing history tab. We can say, so if I've found a problem, so I can say something like the name should be randomized. So there's a workflow built into the editor for doing this stuff. And then finally, once I'm happy with it, I can say ready to use. And this will show up throughout the editor. When we have an exam that uses this question, that tag is visible. Okay, what else do I want to show you? There are automatic unit tests for questions. Automatically, I get one that says, is the correct answer? Is the expected answer marked correct? It's possible to set up a question where that's not the case. So I can do that. For more sophisticated questions, I can add in more unit tests. I might want to put in some wrong answers to show that I've thought about what wrong answers the student might put, and you need to make sure that those are marked incorrect. Okay. Yeah, so not a huge amount of time left. Quite a lot to show you. I think I'll skip back to my slides now. And I've got some more screenshots to show you maybe. So in fact, that screenshot's out of date. I need to update that. So the documentation is the best place to go to learn about Numbas. As I said, it's got references for every feature there is. You can browse through that. There's a page called How Do I, where if you've got a question, don't even know where to begin for a certain thing you want to do, it might be listed there. There's a document on planning a question, sort of containing our experience on what's the right way to go about going from an idea, I have a learning objective, how do I make a numbers question that assesses that? That's worth reading. We use projects for organizing our material. It's really, I think, really important to do that. Quite often people that start using Numbas will just make stuff within their own workspace, and then when someone else comes along to take over the module, they can't access the material or can't find it. So that's good organization, I think, is a good habit. And again, you can further organize material within a project into folders to make it easier to find. I've shown you the editing history tab. I should have checked these screenshots. I need to update them all, don't I? Variable descriptions I've shown you. The random person extension I showed as well. So when you have word problems, it's a good idea to use a representative name. Something I haven't shown, and in fact that's so out of date, I will show you a more up-to-date example. The printed worksheet theme. This came out of Peter Rollett's work. In fact, he's going to give a talk next week, I think, about producing printed worksheets, which he hands out to students. They each get their own randomized values. But the idea was that the task would be something that couldn't be marked automatically, and it might make sense for students to do offline. So that's the thing that you can do in Numbas. We also use this to make backup papers for summative exams. We'll keep going. As I said, there are loads and loads of extensions. There's some for adding interactive diagrams. There's some for different objects in maths, like permutation groups, polynomials, that kind of thing. Statistical functions. Lots of stuff. I haven't really shown you any custom part types other than the trivial one of the yes/no question. I'll go and find the newest thing, which is the spreadsheets extension. So I'll find that. This is something I've just finished. So what this does is adds a data type for variables representing a spreadsheet. You can import from Microsoft Excel, or you can create one from scratch, and you get a table that's editable. So I have to fill in these blocks here, and those can then be marked. So the motivation for this was a colleague in engineering who had to replicate a surveying table where there's just a huge grid of numbers to fill in, and they were using gap fill for that, which was very hard to manage. So the way this is implemented, if I go back to the editor, it's a custom part type. And that means within the editor, I get a nice editing interface where I'm asked for to fill in these spreadsheet objects, which are defined in question variables, and then give some ranges in the spreadsheet that will be marked. I could override the marking algorithm and do something more complicated using custom marking. That's another thing that I haven't shown. In fact, I'm not logged in enough to edit that, but that's the thing as well. Right. We did custom part types. So I think that's spoken for 45 minutes flat with no feedback from anybody. So that's a really quick tour of what Numbas is and what it can do. There's a website, numbas.org.uk. You can email us or post to us on the Fediverse, or have a look at the source code. We're really, really open to answering any questions you have, either over email or in the mailing list, which you'll find on the website. Very keen to help. Okay, so I think I'll stop there. If anybody has any questions now, you can ask them. You can put your hand up here or post them on the Matrix chat. We've got enough time for me to go and show you stuff if you wanted more detail on something.
Okay, I have one question, Christian. Thank you very much for your presentation, and I'm very so inspired about the question sharing system for the by using the math center. Yeah, it was quite nice system, I think. So by the way, is there any math input interface for example, mobile devices or something like that?
There isn't at the moment. I know what you mean. Some of the symbols are quite hard to find on a mobile keyboard.
Yeah.
So it's quite awkward. No, we haven't got that. Had some chats. Someone offered to come in and integrate MathQuill. I reckon that would be that seems to be the way people do it. It's fairly standard. But if I said we haven't had any complaints, that's a little bit complacent, but some people do numbers tests on mobile. I know that in other countries, it's less common for people to have a computer with a keyboard where they can type. So this is more of a problem. So that, yeah, it's maybe something to look at, but I haven't prioritized it so far. I know you've demonstrated all sorts of input methods over the past.
Okay.
It might be worth having a look at that.
Okay, thank you very much.
Okay. Samira, you have your hand up. Do you want to ask?
Yes, I know a little bit about Numbas. My question is that I use the Explorer to get some question from somebody else, write that question. But when I want to delete, I use 2 parts, let's say, and then I want to delete 1 part. When I go to run the test, the question, I could not do that. There's something wrong. They want me to remove the variables, and when I go to remove the variables, I don't know what I did, something wrong, so the test is not run properly. So what's the procedure if I want to delete some parts of the question?
Yeah, so it might be, if there's adaptive marking, it doesn't at the moment. So one part will have a reference to another. If you remove a part, then that reference points to the wrong place and it can go wrong. It doesn't update automatically at the moment. If you email me a link to the question and that you copied and tell me what you did, then I'll be able to see what went wrong.
Right. I'll do that. Thank you.
Yeah, I think you're muted, Yasuyuki.
I'm sorry. Do you know anybody who uses Numbas in Japanese or Asian country?
There are certainly people in China using it. I'm not sure about Japan. I could check.
Okay.
Yeah, I should mention it. It's been translated into around about 20 languages so far. I think there is a Japanese translation now.
Yeah.
Now I think about it.
My colleague and myself translated.
Oh, right. So that was right.
Some years ago.
Right. Yeah.
Already some years ago. So.
Yeah. Because of the way it works and nothing really comes back to Newcastle, we don't know exactly where it's being used. We can sort of guess based on the editor, but yeah, sorry.
Yeah, no problem. Thank you.
Okay, so I'll talk for a little bit longer while if anyone else has any more questions, but I feel maybe not. Okay, so what I will do we've got a couple of minutes left is I'll try and show you what's coming up next in the conference. Get back to my slides. So yeah, right, there we go. I'm ready to share it. So tomorrow morning, we have a talk on technology enhanced assessment, providing options to students. That was a scheme at Middlesex University. I think in short, they handed out tablets, devices to students and supported that. And then on Friday afternoon, there's a free chat session. And the suggested topics for discussion are changes in assessment in the last year and experiences with summative exams. So go to that if you want to talk about those things. Next week, now there's the strike at Newcastle is going ahead. So this is the end of the conference for me. The team from ANTS exam are taking over the slot I did have on Monday. I'm going to give a demo of their system. And the rest of the program is on the website. Okay, so I think we'll stop there. Thank you to those of you joined in and enjoy the rest of the conference.